I'm Dan Corey. I'm a senior architect here at ResultsPositive, and I first used Loadrunner probably about 10 years ago. But I've been working with it full-time for around 7 years, a little more than that. Prior to that, I worked in functional automation with QTP and WinRunner, actually. And prior to that, I was actually manual QA. But I do have a little bit of development experience and also a BS in information technology. So during this webinar, we're really going to take a high-level view of performance testing, but along with that, I'm going to put the technical information in that you need to understand to have the background to understand the business aspects. So we're going to be giving examples from prominent companies. These companies are leaders in the performance testing space and are very public about both their challenges and their triumphs. The examples here are given because they are the leaders, and all of this information is publicly available. At the end, I'll be giving sources if anybody's interested in follow-ups on their own. At first, also a disclaimer, when I have discussions like these at a high level, there's always nuances and details and exceptions, but I'm not going to get into all of these things. So you may catch me saying something that isn't 100% of the technical explanation. So here's the question that performance testing can answer for you. Performance testing simulates users and traffic on your servers, and it will tell you where your bottleneck is. Every server, every system, every computer architecture, everything has a bottleneck, and the question is, do you know where your bottleneck is? And if you don't, then I think that there's a certain business risk associated with that, an unknown business risk. And performance testing done properly will let you know when your system breaks, are you actually going to lose data? You can lose data if your systems aren't writing to a database, for example, and that is a major issue. Or do they break a little more gracefully? Do your systems just slow down and eventually just stop responding to your users? Obviously, you never want to stop responding to your users, but if you have to break, are you breaking the right way? This is the question that we strive to answer in performance testing. And in doing so, it enables you to understand how your business works and exactly how much you can grow your business. So it gives you a greater visibility into your risks, essentially. On screen, we have two very prominent companies who have two very different stories of performance testing. And again, this is something that both of these companies have been very open about in terms of performance, because they are the leaders, or among the leaders, in just extremely high usage. So they have problems nobody else does at the extremes that very, very few companies have them. The first is a story of success. And Mark Zuckerberg was very selective about how he rolled out Facebook. His competitor, his primary competitor at the time, really didn't perhaps pay attention to performance the way that they needed to. The users wanted to use the competitor's service, but they just couldn't get to it because there was so much demand. The servers were either very, very slow or just unavailable to the users. And then this other thing called Facebook comes along to their college, and they join it, and, well, I can use that. So Zuckerberg was very smart about projecting the usage and the demand and making sure he had the system resources ahead of that. And it's regarded by some as a multi-billion-dollar mistake to not have the edge, or to have the edge in the social space, but give it up because your systems couldn't perform the way that they needed to. So clearly, performance testing does matter, and it's important to businesses. Now, on the other side is Twitter, which over the years has had many, many challenges in terms of system demand, and that really is due to the nature of their business also. Facebook is more social. People go on there, check pictures. A lot of time in the past they've updated statuses and traded IMs and such. But when a major event happens, Twitter gets absolutely bombarded with people who want to talk about it immediately. And that's not necessarily as much the case on Facebook. So Twitter has some very unique challenges. In terms of their architecture, they were very open and honest to say that their architecture wasn't necessarily ideal for what they needed. And they had so much downtime in the beginning that they actually had a kind of a euphemism for it. It's called the fail whale, and you see it right here on the screen. When Twitter was way over capacity, it couldn't handle it. When users wanted to use a service, they'd get this whale, and they'd be really bummed out that Twitter couldn't, service what they needed. But the Twitter does have a happy ending. Right now, they really have re-architected their systems. They've done performance testing, and they're able to serve their business or grow their business and serve their users very effectively because actually this traffic that you see here is Twitter graph that I pulled from their blog. And on one day about 3 weeks ago, they got a spike within several seconds that was 25 times their normal traffic. And their service didn't have even one issue or problem. Everything worked as it should have, and they were able to handle all those requests all at once. And their goal is to be able to handle any type of traffic that comes their way regardless of what is going on in the world, which is pretty amazing considering this incredible spike that you see here. Not many systems can handle that. And lastly, here's another big e-commerce site. Reddit is a site whose traffic has doubled every year since it began. And with that, there are incredible problems and challenges associated with that. So performance is really important for a lot of companies. But, of course, very few of us work for Reddit or Dropbox or Facebook or any of these companies that are really at the cutting edge and the bleeding edge of performance. So why do we use those examples? Well, they're very public-facing companies, and like I said, they are the leaders and very open and honest about it. There are just as valuable, more internally focused examples, but of course that's proprietary and we really can't get into specifics on customers. Needless to say, there is certainly a consideration for every single enterprise architecture when it comes to performance. And it really comes down to what I call the 3 R's. Reputation, revenue, and regulatory. Revenue is obvious. If users can't use your site, you're not going to make money. Or you're going to lose money because expenses are increasing or whatever. You're going to be losing profit and probably more than likely revenue. Reputation is also important for this too because if you have a website internally and your users are trying to use it, but it's much slower than what they get at home. For example, say you have an order app for your associates to use, and it's 3 times slower, then the reputation of IT is going to suffer due to that, and user frustration is going to increase, and they're going to be less productive. You're going to have a reputation loss. If you are an online brokerage, for example, you're going to have questions from your users. If it takes you 20 seconds to respond, are you really getting the market order that you need? So it's important for these types of reasons. The last one is regulatory. And this is interesting because really heavily regulated industries like the financial industry are actually mandated to have certain availability and certain kind of what they call white space in terms of their system availability and able to handle extra traffic, these spikes, right? And it was all very academic until the financial crisis hit. There were amazing, it wasn't quite 25 times in most cases, but there were amazing jumps in traffic as the failing banks were getting just absolute bank runs. That's all you can call them, is bank runs. And the banks that were perceived to be more solid were getting account openings, much more than had ever occurred in the past and probably since. So it's not just academic, and if you don't have enough excess capacity where the regulatory body, the OCC, doesn't think you should be opening more branches, then you've got a major problem. So regulations are really a major factor in certain industries under certain conditions. Now, let's start talking technical here. And I'm going to keep it high level, but I am going to start with binary because everything starts with binary. And don't let that scare you, but my intention here is to let you know that everything really comes down to ones and zeros. Everything does. You might be listening to me over voice over IP. At the bottom of it is electricity, ones and zeros, patterns that come out and express as voice. The WebEx you're working on is binary. 99.999% of things in this world are binary. And at the bottom of the line, it's very physical, and it's all electric. Here you see a really cool picture on the left here of a line being run down the west coast of Africa, and right here is where they're hooking the line up to Cape Town. So when people think of the internet and electronics as very kind of ephemeral things that kind of don't exist anywhere, that's not exactly true because it all comes down to the physicality. And in terms of the technology and communication and processing, it always comes down to binary. Now, this is an important slide, and it's important to understand that these three things at the three levels of the pyramid here are exactly the same thing. But down here on the bottom, you see what the computer sees. The ones and zeros associated with this are actually part of the ResultsPositive.com web address. And from there, from the ones and zeros, there's a mathematical transcription that occurs. This is true. This is really mathematical. Certain patterns here are associated with a 68, and a 68 is associated with an H. Why is this important? It's important because you need to understand the notion of abstraction. Humans don't speak ones and zeros very well, or most of us don't. And all but assembler programs really aren't the greatest at hexadecimal, which is what this is called. But a lot of us do speak words, English, decimal numbers. We like pictures, we like movies, and eventually all these ones and zeros get translated up the abstraction pyramid here. So if you get nothing else from this content, understand that there is a translation from binary to understandable content. And there's a certain mapping that occurs between content at a machine level and content at a human level. One last thing about abstraction. The more abstract you go, in other words, the further up that pyramid we go, you're going to have things a lot easier. You're going to be able to build your systems quicker. And if you have errors, they're going to generally be errors of assumption. What do I mean by that? If we go back to the previous slide, well, maybe you think an H is actually a 6F and not a 6.8. So you're going to have a problem in transcription. It's going to be an error of assumption. You're assuming that it's a 6F, but it really is a 6.8. Again, it gets a little bit in the weeds, but basically it's an error of assumption. The less abstract you get, the more powerful your expressions can be. You can get down to literally the hardware and do anything you want, including bypassing security, by the way, which is always interesting. But it's more efficient from a processing standpoint because you can tell the processor exactly what you want to do. And if you have an error, it's usually a mistake. So maybe you think that maybe you accidentally type a 1 instead of a 0 here, and everything breaks because if you have just even the most minute error at the machine level, the processor doesn't know what to do with it. So that's a really, really deep dive, but it's an important dive because you need to understand that there are different ways that different products express these computational patterns. And that's the takeaway from those previous slides. Different mappings occur from these ones and zeros to what you see on the screen here. So ZOS, when it communicates from client to server, has a specific pattern. Oracle will have a specific pattern. Web will have a specific pattern, and X Windows, and all the way down, up and down the line. And this is important in load testing because you're going to be having a lot of different applications in a large enterprise, and you need to handle the different communication styles, the different levels of abstraction. And most things deal with web on the market, and most things are very specific to very specific needs. But on the screen here, you see what Loadrunner can handle, most of what Loadrunner can handle in terms of processing. And this is why this screen illustrates why Loadrunner is still basically, honestly, the only choice you can do on certain types of load testing, unless you want to create your own development environment and create your own framework from scratch. And this is why I personally still work in Loadrunner as a performance test engineer. It's just the biggest and best solution out there. That's why this presentation will focus on Loadrunner, and that's why our company focuses on Loadrunner, because it is a solution for whatever you need to do. It's scalable out of the box. If you want 10 users, it can do it. 10 virtual users, it can do it. If you want 10,000 virtual users, it can do it. So it's very, very scalable without too much effort. There is effort involved in scaling, but it's a very prescribed process. Loadrunner also is very extensible with monitoring features out of the box. And you can add these monitoring features. And it tells you not just what your application is doing, but it tells you what your CPU is doing. It tells you what your database is doing. Whatever you want monitored, it can monitor it. And it has hookups into basically anything you want. It really is the only solution in the market that can do it as well as this is done. Now, in terms of process, this is a really key thing that every time I speak to a client, it's important that they understand. Clients are used to thinking of functional testing. It's around the development process every single day. How are users going to use this? How is it going to look? Is it going to effectively handle the business logic that we need it to handle in terms of exceptions and bad inputs? But performance testing is not functional testing. What does that mean? We listen over the wire. That's why I bring up binary, and that's why I bring up web, and that's why I bring up other communication methods. We don't see things with one exception that I'll go over. We don't see things. We hear things. And what I mean by that is we listen to the network communication, and we play it back to the server, and we measure the server's response. We also don't have a huge interest in exception flows. And that's very different from functional testing, because if there were no exception flows, development would be a whole lot easier if you've ever done development. I mean, you spend 80 or 90% of your time on the exceptions and very little part of your time on the happy path. Happy path is what happens when everything goes right. You know, your customer goes in, they search, they place an order, and they log out. We don't really answer the functional what-ifs, like what if the user puts in an incorrect zip code associated with the address. That's not really a performance testing question usually. And clients will say, well, I really want to test that anyway. And when I explain that would mean basically going up exponentially in terms of the needs of the performance test, people are usually pretty receptive to that. We don't want to do 1,000 different scripts, right? I usually go for 6 to 8. That's usually pretty good for performance testing. There's exceptions to that. Some people need dozens, and some people even need fewer than 6. But that's the general rule. We're really interested in testing the happy path scenario because we're really interested in what is this server doing, right? And it's also, one last thing, is that the number of users or virtual users is important, but the thing that your server deals with is not so much users as it is the transactions that are occurring. And I'm not saying the users are not important, because they are, but your server works by sending and receiving messages, processing the data, writing the database, things like that. And one user can do one thing 10 times, or 10 users can do one thing 10 times, and you end up with the same type of result on your web server. So that's an important thing to understand, but you still don't want users to just go crazy and have one user do all the work, because that's not very natural either. So it's a balance between the two, but people are very, very, very focused on view users, and I like to dial them back just a step or two, because really what your server does is it really handles transactions. All right, so if you can't read this slide, that's okay, because this is the same type of process that we've seen for like 30 years or longer, really. This is the standard waterfall process, and performance testing is just kind of squeezed in there between test and implementation. And really, performance testing generally requires a stable application. I'll usually go into a place that has been developing and testing for months, if not a year or more. And even Agile shops, this thing is a very waterfall-looking graph, but even shops that are Agile and actually conducting the Agile process correctly, even the Agile shops still kind of put performance testing at the end. And that's not necessarily wrong, but there is another option, and I just want to point this out to folks. This option leverages Jenkins, which is a continuous integration product. And what Jenkins allows you to do is automatically kick off a performance test that you've written and report the results back to the developers. That can be important in certain cases. I wouldn't say that you need this in all projects by any means, but that can be important in certain cases, because just like any other form of testing, if you find a performance test bug at the end of your cycle or your product testing, and there's something fundamentally wrong with your architecture or design, that is a really bad thing, right? If you find a crazy functional bug at the very end and you need to re-architect things, you know how painful that can be. Performance testing bugs can be the same way. And getting performance testing in a little bit earlier in the process, or a lot earlier in terms of continuous integration, is a good move for very large-scale, high-visibility products that are going to be put to market. And Jenkins is a really good option to consider on this front, because performance tests are very sensitive in terms of changes, but it will let you know ahead of time what the changes, or the developers, I should say, will let the developers know ahead of time what the changes they're doing, how that's impacting response time. And if a developer puts in a SQL call and does a slight modification to a SQL call, and all of a sudden the web page takes twice as long to load, well, then maybe they should take a look at that. And maybe they should look at the SQL code right then and there when they just crafted it yesterday, instead of trying to remember what they were doing a week ago or 2 weeks ago or 5 months ago. That's a suggestion, and it's something that I like to point out to folks. So I'm going to be doing a demo now, and I'll be showing you the authoring tool that we use in Loadrunner. I'll be going over creating a script at a very high level, and I'm going to be using a protocol here called TrueClient. And again, a protocol is just a way that those ones and zeros are organized, and they're put through an interpretive mask, basically, that Loadrunner uses to put the information into more understandable, human understandable format. This is the recording session here. All right, so you hit record, and we'll just go to ResultsPositive.com. You'll notice that as I go around the website, you're going to see exactly what I'm doing over here on the left. It's remarkably simple. And at this point, web service calls are almost a commoditization. Not quite, but you see things, freeware services that can really do web service calls very, very efficiently It's a little disorganized still compared to Loadrunner, or in some cases it's a lot more disorganized. It takes a programming level knowledge, but really the request response is something that a lot of different tools can do, without too much difficulty. When you start getting into parameterizing data and such, there are certain issues there, but the request response is kind of a commoditization right now. What this is doing at TrueClient, as you can see, it's actually translating what we're doing into English and understandable solutions or understandable content, and putting them there for you to read. I'm going to do one more thing, and I'll do a contact us. I'll fill out a form. You can see as I put it in here, TrueClient is translating what I'm putting in, and I'll just put in some dummy data here. Cloud is always interesting. We're all in Arizona, United States of America. And we'll just say test. And there you go. Your contact is submitted, and you can see it in a very easy-to-understand format here. You can see exactly what happened. ResultsPositive.com. We're mousing over solutions, which isn't that important. And there are tons of things you can do in this TrueClient. Going over TrueClient is out of the scope. I just wanted to show you really what's at the cutting edge of being understandable to humans, being able to be very quick. This is a very high degree of abstraction, if you remember what we were talking about. That's why I went over abstraction so much. This is very, very highly abstracted out to a human-readable form. And you can see exactly what this script is doing. Now, TrueClient is excellent, and it's very, very useful. But just like any other solution, it does make certain assumptions. And sometimes the assumptions that it makes require stepping down in abstraction. And that means that you need to get more detailed. So you saw how easy it was to deal with TrueClient. I'm going to show you something that more advanced users use and employ when performance testing. And this is the web protocol. Here I am doing the same exact thing, but this is at a level closer to the ones and zeros, basically. All right, we'll start recording here, and it should launch Internet Explorer. All right, so we're recording right now, and we'll do roughly the same thing. We'll go to I believe we went to the cloud, Big Data Vertica, which is an interesting product. We went over here to improving your performance business, and we went over here to contact us. We filled out the form, and we'll do this. Okay, we'll fill out some data, and we'll throw this in here, and we'll say we've got this. We'll submit. All right, so we submitted this. I'll show you what this looks like at a kind of a lower level of abstraction. I'll stop the script. And right now the script is generating. Now you'll notice that the script, number one, was not dynamically created because it is built after the fact. It's got a lot of post-processing in there I won't even get into, but there's a lot going on here. And you saw how simple and relatively human-readable the TrueClient script was. This is the web HTML script. And the TrueClient script was what, maybe 10 steps? The web script is over 2,000. And this is what separates the the highly experienced, highly knowledgeable performance testers from the performance testers who may also do functional testing, they may also do manual QA or other duties. A lot of things TrueClient can handle, but when you get into complicated processes or very, very important enterprise solutions, enterprise initiatives, you need somebody who really understands things from the binary level all the way up to the top. And that's why abstraction was so important, because people need to understand the difference between simply clicking on links and allowing the tool to do the work for you and really understanding what's happening under the covers, because sometimes what's happening under the covers is the difference between a good script that works and a script that can't work and won't work until you fix it. There's somebody who needs to know how to fix it, and that's the type of person you should be looking to work with when you need performance testing. Let's talk about how this stuff works. We just saw the ViewGen piece, the very, very top piece. That's where you actually build your scripts. And this is a very, very basic Loadrunner architecture I've put together. There are other pieces to Loadrunner. This entire diagram is basically what Loadrunner is. There's not like one single box that's called Loadrunner. It's got a combination of something called ViewGen, which is the authoring tool we just used, and that's where the real expertise comes in. You have something called the controller, which controls your test and tells the generators down here below what to do. The generators are what actually push the requests out to your system, to your application. And the controllers tell the generator what to do. So you have a lot of different monitoring that you can do. There's a very, very complicated setup that you can involve, but this is Loadrunner at its most basic fundamental level, and it really is all you need to know to understand performance testing with Loadrunner at a basic level. So this is Loadrunner in a nutshell. I do want to show you, again, this is one of those slides that doesn't matter if you can read. I just want to show you how complicated it can really get. And this is Performance Center. This is Loadrunner's big brother. And Performance Center can scale to whatever you need. Performance Center can test and scale up to whatever level you need. You can test tens of thousands of users with Performance Center. You can have performance testers in India, South America, United States, and Europe, and they can all be using Performance Center. Loadrunner is more basic and is still suitable for a lot of enterprises, but if you want and need something that is very, very powerful and very, very extensible or able to be extended, that's what extensible is, you can go to Performance Center with the understanding that it's going to be more complicated but so much more powerful. One last thing I want to say, just because you might be seeing this and looking at TrueClient and saying, this is really, it's not too tricky and it's not too hard, and at a basic level it's really not. You can go on and with a demo or evaluation license, you can go into ViewGen, create a script, go into the controller, and have a generator send requests. One thing I'll mention just for everybody's benefit, don't performance test Google or Yahoo or any of these other sites, because if they receive a lot of requests from you over time, especially very, very quick requests, they will ban your company's IP. And you don't want to be the person that got your company banned from Google, right? So don't test on any services you don't own, and make sure you watch that, because it's very important. Here are my sources. I'm going to keep them up here for a few seconds in case people want to look at them, and they'll be available on the replay. A lot of these sources are really useful. The content ones are. And if you have any interest in it, please take a look and see if you have anything else you want to look at.